This video showcases the work carried out by i2CAT, funded by the UNICO I+D program within the framework of the 6GSMART-ICC project, which i2CAT leads. The project has resulted in the development of i2Edge, an on-premise edge orchestrator designed to support the complete lifecycle management of applications in the industrial edge. In this video, we will provide an explanation of the functionalities developed, with demonstrations covering key steps, from registering infrastructure to deploying applications on that infrastructure. i2Edge, the on-premise edge orchestrator from 6GSMART-ICC, is designed to manage the lifecycle of industrial applications, enabling zero-touch deployment and optimizing performance by placing applications closer to data sources and end users. i2Edge automates key lifecycle processes such as application onboarding, start-stop operations, and dynamic scaling, adapting to both infrastructure resources and application-specific needs. The core functionalities of i2Edge include cluster management, synchronization of availability zone information, application artifact management, application onboarding, and application deployment management. Throughout this presentation, we will demonstrate key platform functionalities using concise videos and animations. Each segment highlights essential tasks and operations that the platform operator will routinely perform, offering a clear overview of the system's capabilities. During this presentation, i2Edge is currently overseeing several infrastructures. These clusters are made up of one or more zones, with each zone having multiple nodes. The next phase involves registering and overseeing an extra infrastructure, usually a Kubernetes cluster. To register the infrastructure, the operator needs to provide the URL for the Prometheus monitoring tool, which monitors resource status, the kubeconfig file for cluster access settings, and a specific name for the infrastructure. Upon successful registration, i2Edge will return detailed information about the zones and nodes within the infrastructure. The last segment of the video will feature the use of Lens tool to demonstrate how i2Edge is managing the new infrastructure. It will also show how to verify the health and resources of the registered infrastructure. After the cluster is registered, i2Edge retrieves information about the various availability zones configured within the cluster. The video will demonstrate the details retrieved from each zone. In the context of i2CAT, an artifact generally refers to a resource, file, or component that is part of a mech service or application package. Artifacts are typically elements required for the deployment, configuration, or execution of MEC applications and services at the edge of the network. In order for i2Edge to deploy a service, it needs first to be onboarded in the i2Edge. Artifacts can be retrieved as a compressed package or as a Helm chart from either a private or a public repository. In the video, we have shown how to retrieve the artifact from a compressed file. In case of being from a public or private repo, we will need to provide the URL and credentials, if needed. At the end, i2Edge shows the onboarded artifact. After the artifact has been successfully onboarded, we must create a profile to enable its instantiation as an application. Once this profile is generated, users can launch an instance of the application. In the video, we can see that i2Edge is already managing other profiles. To create a profile for the newly onboarded artifact, we need to provide specific details, including the artifact ID, component name, potential deployment zones, and application ID. Once the application is onboarded, we can retrieve its details or list the various applications currently managed by i2Edge. This will include the newly created profile, which is now ready for deployment. With the profile established, the next step is to deploy the application. i2Edge must designate the specific zone for deployment. In this scenario, we observe that several applications are already deployed within the test space 1 namespace. To proceed with the deployment, it is necessary to provide the application ID generated during the profile creation, the designated deployment zone, and a namespace, which Kubernetes utilizes to ensure isolation. Upon successful deployment of the application, the Lens tool can be employed to monitor the application's status, health, and the specific node within the cluster where it has been deployed.